Let's get started. We good to go? Okay. All right. I'd like to start with a welcome to country. So I'd like to acknowledge the Gadigal of the Eora Nation, the traditional custodians of this land, and pay my respects to the elders, both past and present. So without further ado, I am very excited to welcome you back to our very first in-person, online, hybrid financial modelling discussion group, Meetup. So welcome, everybody. It's been a long time coming, and a special thank you to Alex Chung over there, who's the co-convener at CPA. So for those of you, hi, hey Alex. So for those of you who are CPAs, please make sure that you have signed in with your registration. You will need to do your registration separately for this event. Okay, and for those of you who are joining us online, feel free to put any questions or comments in the chat. So we'll be monitoring that as we go. If you have any questions for Tim, we'll be going through for about an hour. And any questions in the audience, you can, if it's something you can ask during the session, or you can leave it to the end. So I'll kind of leave that up to you. So we'll be doing kind of both of those. So I'd just like to thank Tim for agreeing to be our very first in-person hybrid speaker. So Tim is a financial modelling specialist based, Tim Heng is a financial modelling specialist based here in Sydney. He is a Microsoft MVP, as am I. He is a director at SumProduct, a financial modelling consultancy. He's done lots and lots of fabulous things relating to financial modelling. Most importantly, he has been the co-commentator with myself with the Financial Modelling World Cup and Excel Esports. So, yeah, I'll hand over to you, Tim, to take us through your presentation for today.
Thank you, Danielle.
Thank you.
Thank you everyone for being here. Thank you for showing up in person and filling up a room. This is fantastic. And thank you to everyone who can't be here and is viewing this online. I appreciate you all bothering to join us, because I'll be honest, even online webinars have been pretty thin on the ground recently. So today we're going to be talking about problem solving with financial models. And this is basically inspired from, as Danielle kind of inferred, the Financial Modelling World Cup. Financial Modelling World Cup, as you've probably just heard us talk about anyway in the last 10 minutes, but for those of us who weren't here during that time and have just signed in, it's essentially taken the world by storm. It's been it's an Excel competition. It's been running for, I think, what, a couple of years now. Danielle, is that right? A couple of years, I think.
Yeah, it was just about 6 months prior to COVID, so.
They've been going for a while, but they've recently started doing these big live streamed battles. And while the Financial Modelling World Cup has been this very financial model oriented set of challenges, the FMWC live events, so the battles that they have, the FMWC open competitions that they have, these have been very much more general Excel challenges, problem solving type challenges, you might say. And so what we find is that a lot of the financial modelers who might have done really well in the main rounds, some of them were able to take those skills and apply themselves and succeed in the problem-solving challenges too. Some of them approached the problem-solving challenges and tanked hilariously, because the approaches that you take sometimes don't necessarily lend themselves well to the out-of-the-box thinking that you need to solve some of these challenges. With all that said, that's basically inspired us to come up with a session around, I guess, what are the sorts of challenges that do come up in these sorts of live events, how you might try and solve some of these challenges, how you can use some traditional financial modeling techniques to do that, how you can use some out-of-the-box financial modeling techniques to do that, and I guess just some of the traps that you can fall into when you're trying to work under pressure and solve problems. So, as Danielle said, welcome questions at pretty much any time. For those of you who are in the room, please feel free to put your hand up. I can see Alex at the back with the microphone, so he'll come around and if you flag that you want to ask a question, we'll try and get that to you. For those people online, unfortunately, you've got a filter. Danielle's going to be looking at the questions, and if it's a worthwhile question, then she'll interrupt me, and we can have a conversation about it. And if it's a worthwhile question that doesn't bear interrupting the flow of the conversation, then we can have a chat about that at the end. How does that sound? All right. So
Sorry, I forgot to mention that we are actually recording this, and we will get the recording out to everybody who registered.
Excellent. So with that in mind, we have a package of cases today. So the cases that we're going to be looking at are actual FMWC cases, in the case of the first three. A story about the reels is a problem that was set in the first round of the All-Stars match that was most recently screened on ESPN2. So yes, again, for those of you who weren't here just before we started, that is Excel competitions being screened on what is basically the premier sporting streaming service in the world. So that was a story about the reels. We'll be going through and talking through a sort of from start to finish solution of how to go about solving these problems and some of the challenges that you go through in the process.
So this is the package from FMWC.
Yes.
I think that's going to be available for the next 48 hours. Normally you need to purchase them, and they've made them available free for us.
That's right. So thank you for mentioning that, Danielle. The QR code here allows you to download these cases for free. Normally, I think they charge $10 US a case or thereabouts. But the guys at FMWC have very kindly asked or offered these cases for us to download, as Danielle said, for the next 48 hours or so. So for those people who are watching online, if you don't snap a shot of the QR code right now, don't worry, you'll get a chance to get it from the recording when that gets released tomorrow. So, story about the reels, talked about that. The second case, chess with no stress. This is one of my favorite cases, actually, because this is a case that Danielle and I co-commentated in what would have been my first commentating experience through the FMWC. So, I've got some spare love for this case. I also love this case because it is the lowest scoring case that I've ever seen in the FMWC competitions, where the top score, or the person who won this particular head-to-head, won it with a score of 5%. That is 50 out of 1,000 points. And so we'll be talking about how we can solve this problem pretty easily through, I guess, some fairly simple transformations, some fairly simple financial modeling techniques, and talk about where the two players who did go head-to-head came stuck. The third case, Knights and Warriors. This is, again, one of my favorite cases. This is the first time I featured on ESPN, which was good fun. This was the finals of the FMWC Open 2021 between Michael Jarman in Canada and Andrew Ngai here in Australia. So Knights and Warriors was the final match, the $10,000 match or $3,000 match, whatever the final prize pool was in that case. And again, there were a couple of very interesting approaches that the two competitors took. I won't actually go into a huge amount of the modeling around this particular challenge because obviously I want to give you guys a chance to have a go and play out the grand finals yourself. But I'll talk just a little bit about how their two different approaches taken by the two competitors kind of led to one succeeding and the other not doing so well as such. Finally, if we have time, we're going to go through a very quick example of a question from ModelOff, which is kind of like the predecessor to FMWC. So ModelOff was a modeling competition back in, I think it was 2011 through to 2015. Rickard, you can correct me on that. Something like that, yeah. And so one of the problems in there, again, I had the opportunity to be able to try out some of those questions and to deliver some sample answers previously, a long time ago. And Purple City was one that really stuck to my memory because it was a classic financial modeling problem where if you tried to solve it using classic financial modeling approaches, it would take you about 2 to 3 times longer than if you thought outside the box and sort of just transform the way you thought about the process. So I thought that was a really good opportunity to talk through that example. Now that example isn't in this QR code. There's a separate QR code that'll take you to a download link for Purple City when we get to that part of the presentation. Yep. All right. Does anyone have any questions before we get going? No? Cool. All right. So a couple of general tips for esports. If you decide after all of this that this is going to be a lot of fun, you want to give it a shot, here are some of the sort of things you want to bear in mind. Read ahead. Anticipate what the problems are going to be. Some of the biggest problems have happened when competitors solve the first problem to the letter and don't consider what their solution might mean for trying to solve the next part of the problem. In general, the problems do kind of solve themselves in the sense that stage 1 tends to be the first step of solving stage 2, and then stage 3 and stage 4 and so forth. But as with any sort of modeling approach, for those of you who do model, and I'm going to make the assumption that a lot of people work in Excel here quite frequently, you'll find that you'll start going down a process, and sometimes that process works and it's fantastic. Other times you'll get down maybe halfway through the process and realize that was not the right way to do it, and then turn around and have to sort of redo everything that you've done and start over again. And so if you can read the questions ahead and anticipate what's going to happen, you've got a better chance of predicting that the right way and not sort of leading yourselves down to the dead end. The second point is to test the example. Now, FMWC are really nice. They don't just sort of give you a problem and say, here, you've read the rules, go ahead and do it. And fingers crossed you get the right answer. They're very kind. They give you a sample answer to say, okay, so if you've understood things correctly, then you should get this as your solution. Logic says that you should probably try and test that and see if you get that answer, which is funny because I think in one of the competitions recently, I'm not sure if it was the All-Stars match or if it was the finals, someone went through and they didn't get the right answer and then thought, you know what, I'm just going to run with it anyway because I trust what I'm doing. Needless to say, they failed miserably. So do test it. Third point, build it so that it's scalable. Often these questions are a case of having a problem that is repeated over and over again. So 30 times over, for example. Each stage has 30 questions, and you need to be able to apply your solution 30 times. So that means if you're going to put a solution in place, make sure you can copy it down 30 rows, and make sure that you're doing all the anchoring and all the referencing and everything you need to be able to do that. Classic financial modeling problems. Which leads us very nicely into the fourth point. If you can't do that, learn how to use data tables. One of the beautiful things about this whole FMWC experience has been introducing the non-financial modeling part of the world to the concept of data tables. If I had $1 for every time Bill Jelen had said, I've never used data tables really before this whole FMWC experience. I remember he was talking to us and explaining that he would not use data tables on a day-to-day basis. It's just not part of the toolkit of problems that he can solve with Excel. Financial modelers use data tables fairly frequently. We use them for scenario tables. We use them for what-if analysis, tornado charts, and so forth. And so for us, data tables is kind of like inbuilt as part of our toolkit for solving a lot of different problems. And when it comes to these scalable solutions, it's the same thing. If I've got 30 problems and I've got a solution, I shove it into a data table and I have 30 answers. Very simple. So those people who know how to use data tables do really well in these competitions as a result. For those who don't know how to use data tables, do learn how to use them, or be smart about how you use rand between. Rand between is the standout function in the FMWC. For those of you who don't know what rand between does, it generates a random number between x and y, generally an integer number. Now, this is great because when you've got one of these problem-solving challenges, you usually need to get a figure into a cell at the end of the day. And if you don't know how to calculate that, then your Hail Mary sort of experience is to dump rand between, pick two numbers that are kind of close to where you think the answer is going to be, copy it down the page. And if you're lucky, one of those answers is going to be correct. And that's going to be one more correct answer than the next guy. Fingers crossed. So the organizers have cottoned onto that. They realized that too many matches were being decided by rand between and started making the solutions have this really big, wide range of answers rather than a narrow range of answers. Because obviously, if all the answers are between like 1 and 20, you've got a much better chance of randomly getting the correct answer compared to if the answers are between 1 and like 10 million. So Be smart if you have the option to do so. And finally, just be smart about the way that you use Excel. There are so many cool functions in Excel. Things like mod, your text functions like left, mid, and right, knowing how to use match, XLOOKUP, offset. See, Ian Bennett didn't make it in today, so I can say offset without getting tomatoes thrown at me. Learn how to use the gamut of functions that exist in Excel, because there are a million ways to do things in Excel. Some of them are a lot faster than others. So tools like mod, for example, if you haven't sort of used them in your financial modeling experience, you should learn, because they're really useful tools to be able to calculate a whole range of different things. So without further ado, I introduce the first of our examples, assuming we don't have any questions and whatnot. This first example is a story about the reels. This was a 30-minute challenge in the All-Stars battle. Like I said, the most recent one to have been displayed on ESPN. The idea is that you've got a slot machine that has a fixed number of reels, so 5 different reels, and each one has 19 different positions on it. And you have a number of different points that you can earn when it clocks onto a different icon. And if you get multiple icons, then it multiplies the points. So, if you have 2 little diamonds, you get the points for diamonds squared. If you get 3 diamonds, you get the points for diamonds cubed instead, and so forth. So, it's a fun little example. And so I'm going to move away from the slides and jump across to the Excel example. So we can see this is the sort of question that we might get. A set of instructions and a little pictorial example of our little slot machine. So on the right-hand side, we're going to see the different slot machine options that we have. These are the 19 segments that exist. On the left-hand side, you can see, if I walk here, it's going to be okay. You can see on the left-hand side that we have a set of scores that are assigned to each icon. It's a lot of fun. So if I scroll down and take a look at the question itself, you'll see that the question is broken up into levels. This first level has been categorized as very easy. Very easy, yes, indeed. What's the basic concept of the game? I've got one roll, and it's one of the strips, the slot machine strips. So the goal is, how do we go from the starting position, which is the very first one that was highlighted at the top, and if it spins around, in this case, 35 times, then where does it land? And how many points do I get for wherever it lands? Seems straightforward, right? All I need to do is start off here and go, okay, 35 spins. 1, 2, 3, 4, 5. It's going to take a long time if I do it that way, right? Okay. So how do we know where it's going to land? So I mentioned mod. Mod is a great function. I love the mod function. So mod is one of those functions where I can say, well, starting off at point number 1, and we're going to move it to we're going to move it 35 positions forward, right? So if I say I'm starting at point 1, and I'm going to finish at what is ostensibly point 1 plus 35 turns of the wheel. So we're going to finish at point 36. There is no point 36. There can't be a point 36. There's only 19 points in the wheel, right? This is where the mod function comes in. So the mod function allows us to create that set of 19 numbers and spin it around so that once I get to 19, I'll start back at 1 again. And so if I were to use the mod function for something like this, I could say, well, let's take mod of 36. We'll divide it by 19 sectors in the spinning wheel. And that'll give me a result of 17. Okay? Now 17, if I were just to sort of take a look through, 17 I think would be, let's see, the bottom one is 19, 18, 17. 17 is a little bell symbol. The bell symbol is the item 30. The answer happens to be 30. There you go. But again, that was that manual approach of cross-checking to see what's working. At the very least, that's for me to say, okay, I'm picking up the mod correctly. What I could do is then have something that looks up what is the icon. The icon is going to be an index of our set. Oops. I play it with someone else's keyboard. The index of these 19 different items, looking for the 17th item in that list, okay? So again, learning how to use our different functions. For a lot of people, they use VLOOKUP. For more people, they use index match. And then there are some people who use index match and have never used index by itself. Index by itself is a beautiful function because a lot of people will think, okay, well, I'm going to match something to get it to work, but it doesn't matter if all your numbers and all your values are in the right order, right? I don't need to match 1 to 19 in this list. I can just say, give me the 17th item. So index by itself is great. So index gives me a bell, which gives me so many points, which I can do something like an XLOOKUP in this case. XLOOKUP, looking for the bell, looking through our list of icons on the left-hand side. Oops. Let's see, list of icons. And my gosh. So for those of you who use Excel Online, this is the experience that you get now. You get this really big set of hints as to how to use your function.
And I just wanted to point out that the icons are in color because they're not in standard.
Oh, that's true, yes.
Yeah. I wondered actually, are you able to hide the ribbon on?
Oh yeah, sure, I can do that.
It just might give us a bit more space.
I can do that. Let me finish this formula and I'll do that. All right, let's hide that ribbon, get it out of the way. Excellent. So, simple XLOOKUP function. For those of you who haven't used XLOOKUP, it's basically your index match. It's your VLOOKUP on steroids. It's the better option to most lookup options. More importantly, XLOOKUP deals with things like Unicode and things with non-printable characters really well. It deals with wildcards effectively and doesn't break in all those situations where you'll find VLOOKUP actually doesn't give you the right answer. So XLOOKUP is giving us 30 points, and then we can match that back against our solution. All right, I'm going to do a quick check to make sure that we've got the right answer. So I'm just going to go points equals the answer. Oof. Don't like using Excel Online, but sometimes you got to do it when the machine only has Excel 2016 installed.
You're brave.
I'm brave, I know. Okay, so for now, I'm just going to give me a 1 if it's correct and a 0 if it's incorrect. And so in this case, I can see it's giving me the correct answer. So far, so good. Now, I need to make this scalable. I need to make sure that I can actually copy this all the way down the page. So one of those nice sort of habits that you get into when you're working with models is you like to use styles, you like to use formats, and whether you're working under pressure or whether you've got all the time in the world, you still want to be able to do this. Because especially under pressure, we've seen a lot of cases in the live competitions where people will get involved, they'll start trying to solve problems, and then they'll forget what they were doing elsewhere because they haven't left themselves enough notes, they haven't left themselves the formatting, the styles to kind of tell them, oh yeah, that's what this was doing. And they make mistakes as a result. So what we can use instead is a style here to just remind ourselves that this is an input. There we go. So that's our input. This, I think, is fine. I can copy that down. The mod function is okay, except mod gives us an answer between 0 and the remainder. So if I were to say start at point 2, that would move me to cycle 18. If I were to move to point 3, that would move me to cycle 0, which is a problem. So I'm going to need to modify this mod function a bit. Let's turn that back to 1. Oops. That mod function needs to be adjusted. Instead of giving me a range from 0 to 18, I want it to be a range from 1 to 19 instead. So the easiest way to do that is to take 1 off the value that you're using and add 1 back in the end. And that just cycles it around so that if I were to flick to 3, it's going to stop at 19 because 38 divided by a 19 is a divisor of 19. Whereas now it's going to try and divide it by 17 instead and then add 1 to the result. So it's just a trick to get the mod working the way that you want it to. What else do I need? I need to anchor down the reference to yes, I get it, thank you. Yes, Excel shortcuts work in Excel Online. Some Excel shortcuts work in Excel Online, not all of them. Got it. Go away. Wish the mouse would work in Excel Online. Okay, can I hit escape? Is that gonna, there we go. Go away. It is trying to be very helpful. Got it, go away. You know what, I'm going to just refresh this and come back to it. You said I was brave doing this in Excel Online, didn't you? There we go. Okay, so my anchoring is now in place. That's working happily. I'm going to need to anchor the references back to the lookup table for the different icons and the points. And then from here, I'm just going to copy all of those down my list of answers for level 1. Level 1 was the very easy one, and I can see, just scouting through quickly, all of them appear to be correct. Hooray! All right. Now, of course, when you're playing this for real life, you're not going to have the scores telling you whether you've done it correctly. You just kind of hope that you've done it correctly. So, you know, just like in exams at school, you double check, make sure that you've not missed off any anchoring, make sure that things copy down. Check for reasonableness. If you have hash values, if you have spill errors that are flying everywhere, if you have 0 values, chances are you've done something wrong, right? So make sure the answers appear reasonable. You know that all of the answers have to be between, 10 and 100. So that gives you a hint as to what the responses should be. Okay. All right. So same sort of problem. Level 2. Every game starts from the first sector, but the next 2 moves start from the last sector of the previous turn. Okay, this is more fun now. So instead of having this starting point of 1 every time, it's going to roll once. We're going to get an answer. And then it's going to roll again from that point. So I might have a starting position of 1 for that first point, right? So I'm going to make that style as an input. And then as requested, I'm going to get rid of the ribbon. But that's for the first point. What about the second 2 points? Well, the second 2 points are going to be from 1 plus 17. So we spun it around 17 times. We're going to get to the point 18. That's effectively going to be the starting point for the next cycle, right? And then the next one's going to be, oops, get my shortcuts. 18 plus 51 spins. 69 plus 19 spins. So these are the places where they're going to land, which means that I can then kind of go back to exactly the same formula that I had before. If I were to copy all of this across, go back down here. So my finishing position is going to be, you know what? I actually don't need this finishing position because I've got these finishing positions over here, 18, 69, 88. So my mod function, point that back to 18. Okay. Here's the other thing. People always say, you know, don't use the mouse when you're using Excel. Pro Excel users don't use the mouse. Financial modelers don't use the mouse. I've spent a long time doing financial modeling and playing around in Excel, and I've sort of come to the conclusion that you do what you need to do. And so if it's faster to use the mouse, use the mouse. And if it's faster to use the keyboard, use the keyboard. 9 times out of 10, it is probably faster to use the keyboard, honestly speaking. So if I were to cut and paste and move this around, I'm just going to use the keyboard because that's faster. But if I've got a value here that I just need to sort of drag it, move it across by 1, often it is faster to use the mouse. So just point and click and go for it, right? Don't waste time doing things that aren't necessary. So what have I done with mod? I've said, let's take the mod of that sort of end position after the first spin and then copied it to the right. Scalability, yep. Okay, the icon. The icon is looking up my first mod position. Again, if I can copy that to the right, then success. I've managed to sort of, again, repeat and use the same tools that I've built previously. I can use the same thing for the points. I can get a total for the points, insert some columns, insert some more columns, please. Total. Oops. 60, yep. And then I can check, is 110, oops, Is 110 equal to the solution on the left-hand side? Yes, it is indeed. Brilliant. So if all that works, rinse and repeat. All of this should be beautifully scalable. And hopefully I'll get a string of ones down my result. Simple enough. These are the sorts of problems you run into with this financial modeling World Cup thing. They're not traditional financial modeling problems, but a lot of the techniques that we're using are the same techniques that we might use in any other model that we build. Like the mod function that we're using here is exactly the same sort of mod function that we might use to turn a period counter into the number of months through a quarter, or the number of quarters through, months through a quarter, I guess, or the months through a year that we're looking at. We're using our index functions cleverly, not just index match because that's what we're taught to do, but index because index is the smart way to do things. We're using X lookups, we're using basic checks, 1-0 flags and so forth. All the same sort of tools that we would use in a typical financial modeler's toolkit. But doing it for fun stuff like gambling, right? That's what slot machines are. Rickard. Yep.
Yeah, thanks. Is that on? Is that working? Oh, I hold it. Yeah, look, I completely get how you're splitting the calculation up into various steps, right? Which makes a lot of sense in real life. I could imagine that people trying to make this faster in the competition would basically nest the functions and do it as quickly as possible. Just curious from your commentator role, do people get stung with the fastest approach and therefore they should have done it this way, or do you find that they actually get away with the shortcuts and therefore save some time?
They do generally get stung. Yes, indeed. So not following the best practice of breaking out your calculations and doing it step by step, people do tend to get stuck. Most of the time, it's that something like the mod function, for example, they forget to do the -1 + 1, and then something breaks, but they don't know why it breaks because all they have is the solution. And so you tend to get into that problem where you've got these nested formulae, you can't work out what's actually causing the problem, and you spend and waste a lot of time trying to fix a phantom problem, essentially. You don't know where to actually find the issue. So yeah, absolutely. What we found is that the people who seem to do the best in the competitions are the ones who actually do the best practice and break it down step by step. I've seen very few examples of people try and combine all the logic together and succeed as a result. Danielle, I don't know if you can comment on that based on what you've seen as well. Yeah, no. Cool. All right. Let's see. I'm not going to go through too many other examples. What I am going to do instead is jump to, I guess, the solution. Where's my answers to this? So here's a file that I built earlier. I know, it's great. And so one of the joyous things about being a commentator on these sorts of events is that we get the questions early. So unlike the competitors who are basically presented with this problem and have to solve it having just seen it 5 minutes ago, we have the ability to kind of pore over and look over it and think, well, how would we solve this in the luxury of our own time?
Smart, because we know all that.
That's right. But the joyous thing about it is that it means that when people are going down certain paths in the actual competition itself, we can say, oh yeah, that's a really good idea. I can see how that's going to lead to a solution. Or alternatively, we tried this and that doesn't work, and they're going to get stuck at this point over here, and sort of actually be able to provide some expert commentary to say, this is a good move, that's a bad move, and this is why it's good or bad, rather than us having to try and come up with that sort of commentary on the fly. We can sort of come in prepared a little bit. So with a question like this, I'm going to jump through. You can see how I've solved it previously. It's basically exactly the same as I'd just showed you just now. As we go down to some of these other problems, effectively all I'm doing is still breaking things down step by step. So where are my numbers ending? What positions are they actually ending in? What are the icons in each of these positions? In this case, there's actually this issue of how do you deal with duplicates? And what happens if you get a duplicate result? So for example, this set of scores here, 5 diamonds gets you 500 scores, but you don't add up the 100 scores. You need to compound them. So we get 100 to the power of 5 instead. So this is where creative use of functions comes in. So if I've got a set of numbers through here, there's 40, 30, 50, 30, 20. I can see 30 is repeated 2 times. How do I tell Excel, or how do I get Excel to realize that it's been repeated 2 times? And how do I then sort of give myself the answer? Well, the unique function. We have a unique function in Excel. This is why I can't use Excel 2016 on the laptop. There you go. So for those of you who are using Office 365, you've got this wonderful capability in Excel called dynamic arrays. Game changer. Whole host of new functions. You've got a whole host of new capabilities. And in particular, you've got the ability for Excel to spill and give you a result over multiple cells rather than have one formula equals one cell answer. Now, the unique function is a great one. If I were to use unique on this data set, it wouldn't actually give me very much because unique works across columns, essentially. So what I've done as a bit of a trick is essentially transpose my five answers and then take the unique result of that result and then transpose it back so it keeps going across. Okay? In this way, I can maintain all of my answers going across the row, making sure I leave space for 5 just in case there are actually 5 answers, 5 unique answers, but giving me the ability to sort of track what the unique values actually are. And then off to the right-hand side, I've just done a little COUNTIF to try and work out how many answers do meet that particular result. Using the hash notation to make sure that my dynamic array for the unique numbers flows through onto the number of times that each of those unique numbers shows up. So maybe I should have added dynamic arrays to that list at the beginning of things you should be using in Excel to be able to solve these problems quickly. It's worth noting. I know, isn't it? Unique, filter, sequence. Sequence is one of the best functions in Excel. Again, for problem solving, sequence is fantastic. Love using sequence.
Yesterday for a company that was using 2016 and it was so hard.
Mm-hmm.
I can't do this, and yeah, I've just had to stick to VLOOKUP.
Alrighty. So final scores. Because I can't sum it up, I need to do that to the power of result. And so, using my dynamic arrays, I'm taking the unique values over here to the power of the number of times they show up, and then sum up the results, which gives me my answer, which is really nice. Like as a solution, it's clean. And if you're able to use the dynamic arrays well, then it does give you a little bit of an edge. I think when they first started using them, people were getting stuck using them because they weren't quite sure how dynamic arrays were working. They weren't quite as familiar with them. They ran into errors trying to use them because there just wasn't a tool that was part of their toolkit yet. Once it becomes part of your toolkit, it's really great. Saves you a lot of time, speeds up your workflow, saves you a lot of space as well, potentially, depending on how you're using your formula. So this brings us to level 5, which is the very final level. Now, this is one that makes it a lot harder. We have 10 turns to play with. So we spin each of the 5 wheels once, and we take the score. And then we spin it again, we take the score. We spin it again, we take the score, and so on. So with 10 turns spin, what's the total sum of all the points that you might earn? Now, if I were to repeat the calculations that I'd done above over and over again, I probably could do that, right? I've got, what is this? From column M out to column AW. So that's about 35 columns or thereabouts. I could actually just work that out. 37 columns. There you go. 37 columns of calculations. I could just repeat that 10 times and have 370 columns of work, right? That's a lot of work. That would take a while. The number of interactions you have with a spreadsheet increases the likelihood of making errors. And so if I'm repeating this 37 times, no, repeating this 10 times over 370 columns, more likely to make a mistake. So what can I do instead? Instead, what we're going to do is have 10 rows of calculations for our 10 turns, effectively. So our 10 turns are basically broken down into a start, what is the cycle, and what is the end. And so for this, it's essentially copy and paste from the previous example, 1 round. The only difference is I'm tracking the end position so that I can feed that into the start of the next starting position. I have an index function that cycles through and works out for me. For turn number 1, what are the results? What are the number of spins that go through? For turn 2, what are the number of spins that go through? And so this little calculation block here tracks for me that big long row and just converts it into a table. Nice and easy to manage. From there, it's just a matter of repeating the same calculations over and over again. That notion of building for scalability, for looking ahead and seeing what the potential trip-ups you might run into afterwards are. If you can reuse your calculations as much as possible, keep reusing them. Applies to our real-world problems as well as these under-pressure time problems. Yes? Oh, hold on. Get the microphone first.
Can we just use the data table here? So we had the input, right? Then we had the same set up the process on the step above.
Yep.
We use the data table, then we just got the file result right away.
Yep, pretty much right. So this is doing this for a single row, but we have to repeat the solution 30 times for all the answers. So we've got one input over here that says we're doing this on row number 1, which is the example row. And if I switch this to say row number 3, that's going to give me all of the inputs and the table. There's 10 turns of inputs from the first row of the challenge problems. And you're exactly right. Using a data table, which I've got over here, this is essentially all of those answers spilled out, where it's going to substitute values of 3, 4, 5, 6 out to 32, which is the number of rows in my table set, 33, 32, 33, can't remember what it was. But substitute it into this row field, which will update all the calculations to give me the answer. So 100%, data table is a great tool that you can use to automate that process of running through and giving you all the answers. For those competitors who haven't used data tables before, what they would have to do is feed in row 3, copy and paste the answer into place. Feed in row 4, copy and paste the answer in place. It's still faster than doing everything manually and copying the whole calculation block, but it's still really slow. And so this question was, people had 30 minutes to try and solve. Now, when it comes to most of these problems, you get a 30-minute challenge and you get halfway through, or you get 3/4 of the way through, or you get a third of the way through. And so the winner is the person who has the most number of points. In this particular instance, in this battle of 8, these 8 all-stars, by the end of the session, there were 4 out of 8 people who had maximum points of 1,000 points because they'd completed the entire exercise. Diarmuid Early, who is the US champion, I think completed it within 15.5 minutes. Andrew Ngai, who I said was the FMWC Open champion, he completed it in about 16.5 minutes. Michael Jarman came 3rd. I think it was David Brown finished at 4th. He scraped in at the 28.5 minute mark. So it's not just a case of making sure you get all the answers right. You got to do it quickly, right? And so tools like the data table, tools like building that scalability so you can just copy and paste things down, that speed makes a difference in these sorts of challenges. And you never know whether the problem that you're solving is one that everyone's going to solve, and so you're going to be really fast to get to the solution, or whether it's going to be something where you can kind of take your time and just, as long as you get the right answer, you're going to be ahead of the folks who haven't got it right. All right. Which brings us nicely onto the second challenge. So again, Danielle, do we have any questions that are coming in online that we want to answer? Cool. All right. Question at the back of the room here.
Amazing, mind blown, all that.
I was just wondering, are there any things that you find people do a lot that waste time? Like any key things that people try that just avoid doing that because it just wastes time?
Open YouTube, open Reddit.
In the challenge. Yeah.
Look at Facebook. No, probably not in the challenge. Things that people do that waste time.
This is when you go down the wrong path.
Yeah, pretty much.
You get down a certain thing and you realize this isn't going to work, and you have to either continue with that or start all over again.
Absolutely. I think it's that point in which you make the call to say, this is not working, I'm going to try again. or I think it's going to work. I'm so close to it. I'm going to try and fix it. Because both of those approaches have valid things, right? If there's only one thing you need to fix and you can kind of cotton on to what the problem is, then it's pretty fast to fix that problem. If you try and fix that problem and you still don't get the right answer, and there's something sort of fundamentally wrong with what you've done, at some point you need to bite the bullet and say, okay, now I'm going to write off what I've just done now. I'm going to start from scratch, start fresh, and give it another shot. Something right?
Yeah, we just had a question online. It's about the whether you're allowed to use Power Query or M code, and whether VBA is allowed in these sorts of Excel challenges, or is it just Excel formulas and functions?
Oh no, you can definitely use all the tools. Yeah, I think in one of the finals matches of the FMWC Open, there was this really complicated challenge about having this city that had been built for you in Excel, and you needed to navigate your way around the roads, going past cars and trucks and bicycles, and how that would sort of take additional amounts of time to get around. And I think 6 of the people tried to solve it using a formula-based approach to sort of measure the time to get from A to B in the city. One person tried to solve it with a VBA approach and tried to basically build a solution purely in VBA to run through all the combinations and do what they need to do. As it turned out, they didn't finish their solution. The amount of time it took to build the VBA solution didn't actually let them get an answer in that sort of, let them compete essentially. So they got knocked out in that round. Interestingly enough, the winner of that round was the person who brute forced the answer and manually measured the time it took by counting cells going from A to B.
Yeah, there's a certain amount of brute sometimes.
Suffice to say, some questions are harder than others, right? And this still segues nicely into the second challenge, this chess with no stress challenge. I mentioned before, this is a 10-minute challenge. This is the one, by the way, for people in the room before that I offered to come up here and have a go at playing around with this, see what you can do in 10 minutes. So it's a single question with multiple stages. How do different pieces move around the board? It's essentially one problem. How does a chess piece move from A to B to C? And it just gets increasingly harder because pawns only move in one direction. They only move by a certain number of squares at a time. You then have rooks, you've got bishops, which can move diagonally, you've got queens, which can move anywhere. But if you were to build a solution that solves everything at once, then that's great. Then you can just solve everything. You don't need to try and build each answer to the problem separately. So let's have a go at seeing what this looks like. So here's our little chessboard. And we have an example of trying to connect. This is a good sign. Yeah, okay. So this is why we have backups, chess with no stress.
Oh, one of the things, while Tim's doing that, I forgot to mention earlier was that we do have some prize packs to give out to those people who are in the room. And those prizes will go to the people who've asked the best questions. So be sure to get your questions in just for those people who are here in the room tonight.
Do have one question though. If I don't have internet here, are we having problems with the live stream at all, or is that okay? Brilliant. Okay, cool. Just wanted to make sure. All right. So back in Excel 2016, those are the good old days. Chess with no stress. So you can see here on the left-hand side, we have a series of different pieces, how they move, where they start off, and what their different movements are. As you progress down the page, they progressively get harder. I've got bishops, I have rooks, I have queens, and finally I have kings. They did decide that knights were going to be too hard to position in trying to tell people how are they moving around the board. So the movement here is fairly straightforward. Like if I look at this queen row, for example, I can see the queen is starting off in H3. She's moving 2 steps diagonally down to the bottom left. She's moving 5 steps diagonally up to the top left. She's moving 5 steps down, and so on. And the idea is, how can you work out what is the final position that she lands in? Now, as I mentioned, this is a 10-minute round. So you need to be able to try and work out all those moves and get an answer within 10 minutes. Simple? Yep, okay. So the top score in this happened to be 50 points, which you might note is less points than you would get than just simply picking up a queen and putting it on h3 and then moving it 2 steps and 5 steps and 5 steps and so on to get your answer. So this is that sort of evaluation point to say, is my formula approach actually working, or do I need to switch to something that is more brute force to get the answer quickly? So that's challenge 1. Challenge 2 is, how do you solve this problem? Because when I was watching this, when we were commentating on this live, we could see what people were trying to do. And so the first thing people try and do is you split this up, right? We've got 2 and then a down arrow. We've got 1 and then an up arrow and so forth. So left, right, simple answers. Yep. So we use left and right. We take left 1 to get the number. We take right 1 to get the direction. Easy. One of the problems that one of the gentlemen ran into in using left 1 to get the results is that when you use left and pull a number out, it comes out in text. All right. And so when you try and do things like sum values in text, it doesn't work. So you effectively need to either convert it using value, using the value function, or you need to use operators like plus, minus, times, etc., to have Excel implicitly convert them to numbers instead. But that sort of set them back by a couple of minutes. And 2 minutes in a 10-minute problem is really painful. That eats up a lot of your time, right? So yeah, that's one of the problems. Second problem, how do you try and solve this? Because if you try and solve this, you are essentially, do you just focus on the ups and downs first, and then do you look at the diagonals, and then do you look at the next steps? So the way I tried to solve it is with this columns X and Y over here. So they gave us, as part of the exercise, the arrows, just so that you don't need to sort through and try and find all the codes and pull them out of the cells to work out what are the different combinations, directions you might have. But when I tried to solve this, I thought rather than stuff around and work through, okay, just up and down or just diagonals and whatnot, let's try and find one grand solution. You've got 10 minutes, you don't have much time to solve this. So for each direction, you've got sort of the relative row and column movement that happens, right? So moving down is moving down 1 row and across 0 columns. Moving up is minus 1 row, moving across 0 columns, just like the offset type approach that you might have. Now, from there, I can take all of my answers and split them out. What are the directions? What are the number of steps that you're moving in each direction? So there's my left and right, okay? Yes, I've used XLOOKUP, so obviously this is not going to work in Excel 2016, but you'll get the idea of how this works effectively. Sorry? So what I've basically done with this is I've gone through and said, well, let's look up those arrows. Let's work out what are the relative movements for rows and columns. And then let's multiply them by the steps that you have and the number of moves that you've got. So what essentially you end up with a net movement of rows and columns. Because one of the things that bogged people down when they were sort of trying to tackle this is the idea that I've got a piece, I'm going to try and move it step by step and evaluate each step at each point in time. But you can circumvent a lot of that by looking at what is the total movement, because it doesn't really matter what each individual step is. You just want to know what are all the moves. So if you can see that there are a total of 15 up steps all in all, and they're offset by 12 down steps, then your net movement is 3 steps up. And likewise for columns. And that just saves you a lot of time, because then you can basically perform 1 calculation rather than 10 calculations. Which gets us essentially, what is our starting position broken down into your index of rows and columns, what's your final position in terms of rows and columns, and then convert that back out into an actual sort of letter location notation, like the chess notation. So all of this took about 6 minutes, well, they're about 6 or 7 minutes, because of all the shortcuts that I was taking, right? So in terms of what some of these shortcuts are, trying to evaluate everything at the same time, building that little index table so I can just sort of sum up the numbers of plus ones, minus ones, and accumulate those over time. Using dynamic arrays so I can do all of my this times that in a single cell, and not having to do these 10 different steps over and over and over again. And then the rest of it is just boring old Excel to work out what are your values and stick them all together. Okay, so basic tools. have a go with this. This is the sort of speed challenge, right? Under pressure, it's hard. So I don't judge the people who got like 5%, 4% in this, because when you're trying to do this, you've just been shown the question and you have no sort of background as to how to solve this. It's challenging, right? Under pressure, you don't necessarily think of the optimal solution. It happened that when I looked at it, that was the solution that came up, and that worked really well, and that's great. In some of the longer questions, like the half-hour questions, you've got a bit more time to think and stop and work out, do I want to do this or do I want to do that? In these sort of speed blitz rounds, it's you find a solution and you just run with it and you try it, and if it works, that's great. If it doesn't work, it doesn't work. Sorry, not your day. All right, we've got a few minutes left, so I'm going to see how quickly I can pull up a couple of the other cases. So if I jump back to...
It's going to be a speed round.
A speed round, indeed. So Knights and Warriors was an interesting one. This was the finals of the FMWC Open. Now, Andrew Ngai, who I mentioned was Australian, Michael Jarman, who is Canadian, they battled it out to try and work out which is going to be the better modeler. Now, the thing that I find interesting about this is the approaches that they took to their modeling. Because Michael Jarman took this more traditional time series approach to modeling. Build all your labels down the page. Build your timing or your number of rounds that you're competing in across the page. Andrew, on the other hand, went for a more minimalist approach where he had very small columns with single characters to represent this value or that value or this other value. And his goal was to get as many calculations as he could on the screen at a time. And the reason I highlight this, because I don't think it had a huge impact on the results, to be honest, but I do feel like it has an impact in the sense that one of the reasons that financial modelers like to build down the page is because when you have labels, you don't want to extend the size of your column to see the whole label and only end up with like 3 visible columns on the screen. Generally speaking, you want to build down because you can fill like 20 rows of calculations and see how those calculations go from top to bottom. In this case, it worked the opposite way around. Michael, on the left-hand side, was the one who had to jump up and down and keep having to scroll to try and find where his answers were, his previous answers. Andrew had all of his answers right there because he had nice thin columns and he was able to see the whole picture from left to right. And when you've only got half an hour to work on things, I think that makes a lot of a difference. Just simply the way that you lay out your solution is going to impact, I guess, on how you actually approach the answer. Like how quickly or how readily you can solve it.
Question saying which one was Andrew's?
Andrew's is the one on the right, the one who could see his entire data set at each point in time.
And just another question from someone online saying a lot of the time it's difficult to understand the question under pressure, just to get to grips with what it's saying.
Yes.
Do you have any tips for how to do that quickly?
Make it relatable. So I mean, this is a great problem. This problem, where is it? If I can find my online, this problem here was a very big question, actually. Let's go to the example. They had a lot of description as to how this question worked. They gave people like 10 or 15 minutes reading time to try and work out how to make this work. The thing for me about this question that I really sort of clicked with this question is that in my spare time or for all my faults, I like to play a lot of computer games. And so this notion of having knights and infantry and archers and attacking once and getting retaliated back and whatnot, not only is that something that kind of appeals a bit to my gamer sort of mind, but for anyone who's played the computer games Heroes of Might and Magic, this is essentially pretty much exactly the system that's involved in that game. And so for me, when I was looking at this problem, I was like, that's exactly how it works. Okay, that kind of solidifies in my mind an idea or an approach that I can take to try and solve the problem, because it's not just words on a page, it's not just numbers and formulae and whatnot, it's now a concept, and I can model concepts. And so as long as you can get the concept in mind, I think that's really the challenge. It's forgetting about sort of mechanics and just trying to understand, in principle, what are we trying to actually do here, and make it relatable to make it easier. So one last very final point, because I am going to run out of time with the rate that I'm going. Talking about layout. The final challenge is Purple City, and so there's a download link here from the Eloquence website, who are the ones who sort of inherited all the model off gear at the end of the set. 24 teams, 60 games, 7 final games. This is an underwater football championship, I believe it was. Dates for the first game was 6th of May. The final was run on the 18th of June. Classic financial modeling problem, right? I've got a time series, start date, end date, let's model it all up. Games are held here, costs are this, dollars are this, et cetera, et cetera, et cetera. But that's the wrong way to approach it. It's the wrong way to approach it, because that's the way that a financial modeler might immediately jump to. When you look at a set of data that looks like this, where you have costs and you have, oops, I need to scroll down one more. Is Excel going to do this for me? There we go. You've got a set of dates for all these matches. You're thinking, okay, well, I'm going to do something like SumIfs through this list, or CountIfs, and try and work out when they all show up. The correct answer to solve this problem is not to do it based on days, it's to do it based on rounds. So round 1, these are the teams that are playing. Round 2, these are the teams that are playing, and so on. And so you've got 10 rounds. So you model the 5 rounds, or whatever it was. You model the 5 rounds. You model the quarterfinals, semifinals, finals as separate columns. And that's it. It becomes so simple. And you don't need to worry about a lot of the date time series, because you're converting the question into a layout that best suits the actual problem, the concept of the problem, right? When we look at the NRL, or we look at any sort of sporting competition, the English Premier League and so forth, we don't look at it in terms of the dates that they occur. We look at it in terms of round 1, round 2, round 3. Same principle here. So don't get caught up in the notion of, this is a financial model, I'm going to use dates, I'm going to use all these traditional things that I would build in a financial model. Think about the concept of what it is that you're actually building. All right. So if you want to compete, if you want to play along next time, check out as a student, I think I mentioned before, check out the University Championship. I believe they have a competition that starts in a month's time. The FMWC Open itself starts I think in October, I believe. And if you want to be able to sort of try these problems out and learn how to solve them, you can check out our website. Our website has a bunch of articles, blogs, and examples, various other forums that you can check out. If you're on Discord, if you're on Reddit, if you're just plain and simple, just like the tech community at Microsoft, go check out these different resources. There are lots of helpful people who are there to answer questions, other MVPs who answer questions on the Microsoft forums and on Reddit and on Discord and so forth. So a lot of really great places to get really good solutions. So with that in mind, I think that's about it.
Thanks so much, Tim. For everybody who's joining us live on the webinar, we're going to shut it down now. For those of you in the room, we're going to hang around for a little bit longer. Bye, everyone. Okay, so we have a